Prediction on price on Airbnb in New York City, done by Team Forecasters. Hi, I'm Arifa, and the business goal is to plan promotional activities in advance based on trends found in data to attract more users. It is also to adjust the pricing of properties on Airbnb website to ensure a pleasant user experience and property owners are benefited. So our forecasting goal is to predict the price of property on Airbnb based on Airbnb data in 2019. And also, we would like to suggest for improvements to assist Airbnb to achieve their business goals. Now, let's look at our data, which we sourced from Kaggle.com. And we had 48,895 observations with 16 features. And there is only one feature, target, which is price. And our data set was quite complex. It's because we have a low number of missing data and there was no repeated data, which means it is a very high quality data set. We also had quite a number of unique values which came from features such as name, hostname, ID, and many more. So this will cause difficulties in our forecasting. Hence, not all the features are significant, which we would have to reduce the features for better results in our forecasting. Last but not least, we had different data types such as categorical data in a vector form instead of a factor form. Now, our algorithm and techniques starts from our data inspection and cleaning. Then we moved on to data pre-processing, where we prepared the data for modeling. Then we tested our model with our test dataset. And if it gives us a high accuracy, then we would finalize the model. If not, then we would have to remodel it again. Now, let's move on to data preparation by Hazika. Thank you.
Hi, I'm Hazika and I will explain about data preparation process and exploratory data analysis. First step, we have to examine the data structure and summary to know the data type. Then we drop irrelevant features such as ID, host ID, or last preview because it is very unique and irrelevant for our study. Then we remove missing values and outliers. For example, there is data with zero value for rental price. So we remove this data because it is very impossible for rental price to be zero. Then we changing the data set structure according to our model that we are going to use. For example, regression we use numeric, and then for decision tree we use numeric with vector, and for net base we use vector. For exploratory data analysis, we analyze the distribution analysis where for distribution of price we can observe that the plot is right skewed and the price is concentrated around majority on 50 to 150. And then for the number of properties in each neighborhood group, we can observe that Manhattan and Brooklyn has the most listing properties. For factors affecting the price, on the plot of distribution of price according to review, we can observe that the higher the number of reviews, the lower the price. This is maybe because the higher review is because it is old properties, so it can have a cheaper price. Then on the right plot, which is the distribution of price according to neighborhood group, we average the price according to neighborhood group, and then we can observe that Manhattan has the highest price. This may indicate that Manhattan has the higher living cost. Then we study the factors that are affecting the price. On the distribution of price according to the room type, we average the price, and then we observe that entire home apartment have the highest price. This is logic because entire home have more space compared to private room or shared room. Then we study the proportion of property type in each area. So we hypothesize that the average price by neighborhood group is influenced by the property type of the area. As a result, we can see that Manhattan have the highest average price. It is because Manhattan have the highest property listing from entire home apartment compared to other neighborhood group.
The next data visualization is to visualize the price distribution summary by neighborhood groups. From this data visualization, we can see that Manhattan has the highest mean price value and the lowest is from the Bronx. We will be able to see the next data visualization that Manhattan actually has more entire apartments and home listings that are a little bit on the pricier side. We can also see from here that geographically the Bronx and Staten Island are actually close to each other. However, Staten Island still has a higher mean price value. This could probably mean that Staten Island is a more popular spot, or housing prices in Staten Island are a little bit more higher than in the Bronx. The next data visualization is also for price distribution summary. However, this one is a little bit different as it segregates the data not only by the area but also by the type of listing. There are three main types of listings: entire homes and apartments, private rooms, and shared rooms. Now, firstly, we can see that Manhattan has listings mostly in entire homes and apartments and private rooms. We can also see a difference between these two listings here in the range of price. Entire homes or apartments has their prices range on the higher side, whereas the private room is a little bit more well distributed, so we can say we can look over to other areas that have private rooms as well, and we can see that the prices are quite average. So we can say that prices for entire private rooms are much lower compared to prices for entire homes and apartments. Now if we look at the rest of the data, we can see that the rest of the neighborhoods or the rest of the areas have more listings in private rooms compared to other types of listings. So we can say that Airbnb listings for Manhattan are more on the expensive side compared to the rest of the area in New York. The next visualization is for the neighborhood groups in New York City. Now here we have a heat map that has been produced. From the heat map we can see that there are clear boundaries between each area: Manhattan, Bronx, Brooklyn, Queens, and Staten Island. Now this further justifies that the data has been cleaned and is ready to be used for predictive modeling. Onto our right side here we can see a correlation heat map. Now the correlation between the variables are important to determine which feature is affecting the price so strongly. And we can see here that for price there isn't much of a correlation that is strong. However, the strongest correlation that we can see is between availability and calculated host listing count, which has a correlation between 0.2 to 0.4. Let's look at predictive analysis. For predictive analysis, we need both training set and test set from our data. So we use 80% of the data for our training set and 20% of the data for our test set. Now, training set is to learn patterns from the data, whereas the test set is used to understand the behavior of the model on unseen data. Now, the result from both is that the training set will help model that makes near expected predictions, whereas the test set helps to give us more insight on how to use the parameters of the data. The first model that is used for our predictive analysis is linear regression model. Now this is the first model. The result that we got from our first model is that residual versus fitted plot, there are lines that are close to forming a straight line. Now this shows that the model holds a linear relationship. The normal QQ plot shows that residuals are in Gaussian distribution as the points lie close to a straight line. The lines that we're talking about is the red line seen in each of the graphs. Scale location plot, however, shows that a red line is approximately parallel to the x-axis, indicating that there is an residual increase as the graph approaches the right of the x-axis. The R2 score for our model is 42.1489%, and the RMSE score is recorded as 41.94381%.
To improve the linear regression model, which only use features discussed in the EDA, we add more features into the linear regression model to generate a second model, which we can see the predicted price of this model is actually close to the actual price, which means that this model is performing very well. From the output itself, the residual versus fitted plot, the red line is not a straight line. This indicates that the features might not be linearly related to the output itself, they might be non-linear relationship. In a normal QQ plot, we can see that the data points lies close to the straight line, which indicates that the residual is in Gaussian distribution. The third scale location plot, we can see that the red line is not parallel to the x-axis, indicating there is no heteroscedasticity. The R-square score of this model is 43.86%, which is 1% higher than the previous model, and this might indicate that the features that are not discussed in the EDA might not be as significant as the features that we discussed in EDA itself. This is the linear regression model where you can see the actual price and the predicted price surrounds the linear line that we generated. The next problem that we want to address is $50 considered cheap or expensive? If we compare it with $100, it is cheap, but if we compare it with $25, it is expensive. So instead of knowing the real price itself, we want to know the price range, so this leads us to the classification problem, and to achieve this, we need to discretize the price, which is the output. The first model, classification model that we use is the decision tree model, and this is the decision tree that we generated. We can see that the accuracy of the model on the training dataset is 76.22 and the accuracy of the model on testing dataset is 75.68%. These two values is close to each other, so indicating there's no overfitting, and the p-value is less than 2.2 to the power of -16, so which means that this model is significant to use in generating predictions. The second model we use is the knife-based model, and when we heard of the word knife payers, we think about probabilities. So to do probabilities, we need to convert all the data types into factors, which is categorical data. From the output itself, we can see that the accuracy of the model on training dataset is 75.42%, and the accuracy of the model on the test dataset is 75.55%, which is slightly lower than the decision tree model, because a knife-based model always assumes that all the features is independent of each other, but in reality, it is not the case. And we have seen from the first part until now, we have done descriptive analysis, diagnostic analysis, and predictive analysis, and we identified that location, room type, and the number of reviews are the three most factors that affect the price the most. And in this discussion section, we're going to do prescriptive analysis. We want to suggest some suggestion to Airbnbs, where the first one is to examine the filtered outliers, as they might be overcharging the user, which can affect the user experience. The second is to do more promotion activities at Bronx and Staten Island, because the income at that part is very small. The third one is to include the review result instead of number of reviews only in the analysis, because the result of the review might affect the price of the properties and the homestay itself. Next is to encourage more listing at Manhattan and Brooklyn to fill in the accommodation needs, because a lot of people is traveling to these two places, and we need to ensure that there's always a need to fill in there's always a supply to fill in the need. The next is to upgrade the property value in Staten Island and Bronx, because they need more listing of entire home apartments so that more people can visit there and they can get a income. And the last one is to advertise the predicted pricing on properties on their application in Airbnb. As conclusion, we use linear regression model to predict the price per night, and also we use decision tree and knife pairs to classify the price range of the property in Airbnb. From the data visualization, this dataset is good to work with due to the accuracy obtained, and to improve the whole entire project, we can use artificial neural network (ANN) to find the hidden patterns, which is more sophisticated, and Airbnb can integrating this predictive model into their search engines. So all the codes are uploaded on RPubs. You can follow the link to see the codes.